Today we'll be looking at why all Etch-a-Sketch translations are isometries. Before looking at why this happens, we must define what an isometry is. Sorry, technical difficulties. All right. An isometry, as defined in class, is a transformation that preserves distance. The literal meaning is same isometry, distance. There are three types of isometries in Euclidean geometry. The three types are rotations, reflections, and as you can tell by the large red print, translations. In this video, we are going to focus on translations, specifically translations in Etch-a-Sketch geometry and why they're all isometries and preserve distance. The definition of translation is to move a point or numerous points a fixed amount of spaces in a fixed direction, up, down, left, or right. This definition remains the same in Etch-a-Sketch geometry. Here, you see an example translation in Euclidean geometry. The translation tells us to go left 1 and down 2. Our original point A is located at 3, 2, and our new point is located at 2, 0. This is because we went left, or negative 1, and down, or negative 2. So why are all Etch-a-Sketch translations isometries? Because abstraction tells us we can. Please notice this wonderful Etch-a-Sketch picture. Abstraction is using letters, an abstract idea, to prove there are or are not infinite ways to solve a problem. In the case of translation, in Etch-a-Sketch geometry, abstraction proves that there are infinite solutions. In Etch-a-Sketch geometry and while performing abstraction, instead of numbers we use letters. Instead of 3, 2, and 2, 0, like in our Euclidean example, 3, 2 being here and 2, 0 being here, we use X and Y for our original point A and A and B for our new point A1. Instead of left 1 and down 2, we will use C and D. C is the amount right 1 goes, and D is the amount up 1 goes while performing translations. C and D can be negative numbers. Because an isometry preserves the distance, we must first look at the initial distance of the points being translated. The initial distance is the absolute value of x minus a plus the absolute value of y minus b, because x here is our original x-coordinate and a is our new x-coordinate. The same goes for y and b, except those are old and new y-coordinates. Subtraction here allows us to find the distance between the points, so the distance between x and a, and the distance between y and b, and then the addition allows us to find the total distance. We use the total distance. We use the absolute value signs because we cannot have a negative distance. One cannot go negative 3 miles. Next, we'll perform the actual abstraction. Here you see a formula, the absolute value of x plus c minus a plus c, plus the absolute value of y plus d minus b plus d. We do this because c is the amount right 1 can go, positive or negative, and d is the amount up 1 can go, positive or negative. We use absolute values again because you cannot have a negative distance. Here you can see you have 2 c's and 2 d's. So in normal geometry and what we know, these cancel each other out. Oh, that's not what I wanted to do. But here you see these cancel each other out. So the c's cancel out and the d's cancel out. Which now you can see you are left with x minus a and y minus b, which, as you can see, is our initial distance as well as our final distance. Because the definition of isometry is preservation of distance, this is why all translations in Etch-a-Sketch geometry are isometries. Thanks, Brett. Have a great long weekend.